Hello again. In this video, I'm going to go over section 3.7, which is about the chain rule. Now, the chain rule is another rule that we can use to find the derivative of certain functions. In fact, we use the chain rule to find the derivative when we have a composition of functions. And there's actually two forms of the chain rule. And in this video, I'm going to introduce both of those forms. So let's look at the first form. So to understand what the first form of the chain rule says, let's look at this example. So Yancey picks apples 3 times faster than Yuri. And Yuri picks apples 2 times faster than Xavier. So the question is, how many times faster does Yancey pick apples as compared to Xavier? Okay, so we're going to look at this in terms of rates of change. The first statement says that for every apple that Yuri picks, Yancey would be picking 3. And so we can write this in terms of a rate of change. The rate of change in Yancey as compared to Yuri, which we can write as a derivative, dy over du, would be 3 to 1. So for every 1 apple that Yuri picks, Yancey is picking 3. And so that means as a rate of change, the derivative of y with respect to u is equal to 3. Okay, now the second statement says that for every apple that Xavier picks, Yuri would pick 2. And so in terms of a rate of change, du over dx would be a ratio of 2 to 1. For every 1 that Xavier picks, Yuri would be picking 2. So again, this is a derivative. It's the derivative of u with respect to x, which gives us the rate of change in u as compared to x, or with respect to x. Now the question is, what's the rate of change in the number of apples that Yancey picks as compared to Xavier? And so if you write that in terms of a derivative, it would be dy over dx, the rate of change in y as compared to x. Now, we can find the rate of change in y as compared to x by taking the rate of change of y as compared to u and then multiplying it by the rate of change in u as compared to x. And this is why it's called the chain rule, because we're linking y to x by going through u. We're comparing y to u first, and then we're comparing u to x, and that gives us a comparison between y and x. Okay, so we know this is equal to 3, and this is equal to 2. And so when you multiply those together, you get 6. And so the rate of change in terms of Yancey as compared to Xavier would be 6 to 1. In other words, for every 1 apple that Xavier's picking, Yancey would be picking 6. And that should make sense, because when Xavier picks 1 apple, Yuri is picking 2. And then that would mean Yancey is picking 6, because for every 1 that Yuri picks, Yancey's picking 3. So if Yuri has picked 2, then Yancey would have picked 6. And that's why this is a ratio of 6 to 1. Okay, so this is one form of the chain rule. Now let's actually talk about this in terms of functions. The way this would work is you would have y written as a function of u first. So y would have to depend on u. And then u would have to depend on x. In other words, it would have to be a function of x. So you need to know what these relationships are first. But as long as y is a function of u and u is a function of x, and you want to find the derivative of y with respect to x, then you can use the chain rule. So you can see what the problem is. If y is written in terms of u, then you can't find the derivative of y with respect to x directly. But as long as you know u in terms of x, then you can find this derivative the derivative of y with respect to x by taking the derivative of y with respect to u, which you do know the relationship between those two, and then multiplying it by the derivative of u with respect to x. And again, we're presuming that you know the relationship between u and x. So these are kind of the conditions that are required before you can use the chain rule. You do need to know that y as a function of u and u as a function of x. But once you know those, then you can find the derivative of y with respect to x by using this chain rule. Okay, so that's the first form of the chain rule. Okay, let me show you the second form of the chain rule. Okay, to show you where the second form of the chain rule comes from, let's say y is written as a function of u, and then u is written as a function of x. Now remember, those were the two conditions that we needed to use the first form of the chain rule. Okay, so let's suppose we have both of those. Now if you think about it, that would mean, if y is equal to a function of u, right? Y is equal to a function of u, and then if u is a function of x, right, g of x, then you can replace this u with g of x because they're equal, right? U is equal to g of x. And so that means y is equal to f composed with g of x, or f evaluated at g of x. Okay, and let's say we want to find the derivative of this composition of these two functions, f composed with g. Okay, all right, well, f composed with g of x is the same as y. Okay, so the derivative of this composition is the same as finding the derivative of y with respect to x. Okay, but then, and of course you can write this like this. It's the same thing. And then by the first form of the chain rule, we know that this is equal to the derivative of y with respect to u times the derivative of u with respect to x. Okay, again, that's the first form of the chain rule. Okay, but then what's dy du? What's the derivative of, what's the derivative of y with respect to u? Well, another way of writing that is simply f prime of u, right? It would be the derivative of this function, which we can write in prime notation. So let's write that as f prime of u. Because, f of u is equal to y, right? Okay, and we're taking the derivative of y with respect to u, in other words, f prime of u. Okay, now the du dx would be the derivative of this function with respect to x, which is just g prime of x. That's another way to write that derivative. Okay, and then let's just replace this u. U is equal to g of x, right? So another way to write this is f prime evaluated at g of x, since g of x is equal to u. Okay, so this tells us that anytime we take the derivative of a composition of two functions, f composed with g, it's equal to f prime evaluated at g times g prime. And that's the second form of the chain rule. So there's two ways of writing the chain rule. Okay, this is the first form of the chain rule, and this is the second form of the chain rule. Okay, so that's just a brief introduction to the two forms of the chain rule. In some other videos that we're going to talk about in this section, we'll actually apply both of these forms of the chain rule. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.